if a relation is a function, it means the domain values, or each domain, goes to only one range. I like to think about it in terms of a soda machine. If I press this button on this Pepsi machine, I better get Pepsi. If I press this button and all of a sudden, this Mountain Dew Code Red comes out, I may be happy with the Mountain Dew Code Red, but the machine is broken. It's no longer a functional machine because I pressed the button and I ended up getting something I wasn't expecting. So each X value, each domain, should have one range that it goes to and not two. If it doesn't do that, if you can sort of have a domain that goes to multiple ranges, which would indicate I press the button and sometimes Pepsi comes out and then sometimes something else comes out, that's not a function because it's not a functional machine. So let's look at a couple. We're going to determine whether these are functions or not. And I'm just going to do them in light of, okay, can I make a mapping diagram? Because a mapping diagram is a great way to show that kind of relationship. So I've got this one, and I've got this one. So for my domain values, I have -2, and I think this is the one from before, which is very convenient. 0, 1, and 4. And on the other side, 1, 4, 5, 6, and 8. Now, I'm going to draw them out. You'll notice, by the way, just on the character here, the number of domain values is less than the number of range values. Just to start building the idea in your head of how the patterns work. So -2 goes to 1, 4 goes to 5, -2 goes to 1, or yeah, -2 goes to 4, sorry. 0 goes to 8, and 1 goes to 6. Now, in this situation, each one of these represents a different button on the machine. If I press the 0, I only get 8. That's a good thing. But in this case, for -2, I press the button and I might get 1 or 4. I could get Pepsi or Code Red. I don't know what's going to happen. So this is not a function. If the machine doesn't work, you know it's wrong. Not a function. So let's do the next one. Hopefully we'll have a little bit better luck. Who knows? 0, 3, 4, and 6. And if you would like to, you could always do the whole domain and range, domain and range. That's totally fine. Nobody's going to fault you for making sure you're careful. It's a good idea, especially in the beginning. And then I'll deal with 1, 2, 5, and 7. Oops. So 0 goes to 2, 3 goes to 5, 6 goes to 1, and 4 goes to 7. So in this case, each one of our buttons only go to one number. So yes, this is a function. And finally, one more. Finally, for this part of it anyway. Looking at my domain values, I have -6 is the smallest, -4, -3, and -1. And from my ranges, 2, 4, and 5. Sorry if the red bothers your eyes. It's starting to bother mine, actually. Should have thought about that. So -6 goes to 4. -4 goes to 5. -3 goes to 2. And -1 goes to 5. So in this case, this goes to one thing, this goes to one thing, this goes to one thing, and this goes to one thing. So this is a function. Now you may ask yourself, well, hey, wait a minute. This one has, the number 5 has 2 numbers going to it. Well, in that case, you're looking at something like this machine from earlier. You'll notice that there are 2 different buttons that will give you Pepsi. Well, if you press one of them and it gives you Pepsi, and you press the other one and it gives you Pepsi, the machine is still working. It's doing exactly what it's supposed to do. The problem would be is if you pressed a button and got something different. That is not a function. But in this case, the buttons are just doing what they tell me they're supposed to do. They just happen to be giving me the same thing. Because both buttons were identified to give me the same thing, so they did. That's still a functional situation. So that's, is it a function, using a mapping diagram. Another way we can determine whether something is a function is through using the vertical line test. If we have a function that's in graph form, all we need to do, since the domains are inputs and the y's are the outputs of the range values, you'll notice based on this sort of setup right here, if we have an x that has two y values, it means it's not a function. So what I'm looking for over here is if an x, so anything that would follow a straight line through them, has two y values in it, I know it's not a function. So what we'll do is use this as our vertical line. So I'll just make a test, and you can just draw straight up and down lines on your paper. I just figured you'd prefer to see it this way because I can't draw straight lines. But you'll notice at each point of the vertical line test that this one says, no more than one point at any vertical line, so we could say that's a function. Now down below, you'll notice that it hits twice. This one hits here and hits here. So if that's the case, it's not a function. So I'll just put not there to show that it's not. So I'll go through the rest of them. Uh-oh. Not a function. That looks good. That looks good. Uh-oh. See how it's hitting both of those? It's hitting here and here. Not a function. Here, looks good all the way through. There's no point that's hitting the yellow line, hitting it twice. For this one, everything's looking good. Now it looks a little, kind of sketchy there at the bottom, but as long as it's trying to move up just a little bit as things move forward, you're looking good. There's no point where it's hitting any two lines twice. Even right here, it seems like it is, but only just right there. That's the only point. Up here is not hitting. As long as it's moving up even a little bit over time, it's still a function. So I would say, in this case, that I have a function. My screen popped up. I've given myself away as being a comic book nerd. I think it said something about Marvel on it. In this case, it's looking good, so that's a function. And in this case, obviously, it's not. So if you have a vertical line, it's not going to pass the vertical line test. So not a function, and this is a function. So there you go. That's the value of the vertical line test. It can tell you if it's a function or not, just based on, drawing vertical lines and seeing if they match. You can use a straight edge, like a ruler or something. Do the same thing. That way you don't have to draw as much stuff if you're not that type. Finally, let's talk about the last thing, which is reasonable domain and range. Now, a reasonable domain and range occurs when I'm limited in some way. So the most common example of this is in cooking, and I think in the book it uses a cooking example. So we'll, kind of use the same thing, but I'll talk about roasting turkey. Now, for roasting turkey, you would say something along the lines of, 15 minutes a pound to create it. So 15 minutes per pound of turkey. The problem is, so what I'm trying to do is figure out how many minutes it's going to take to do it. The problem is I may be limited by turkey. The amount of turkey that I have I may have a 12-pound turkey. That's the most that I have. So a reasonable domain and range would tell me all possibilities of what amount of turkey can I use versus how much time would it possibly be. So in order to look at it from a graph situation, I would have 15, 30, 45, 60. These are in minutes, by the way, and on and on and on. For turkey, I have pounds. 1 pound, 2 pounds, 3 pounds, 4 pounds. So that'll be turkey minutes. I'm not going to do the whole graph, but you'll get a feel for it. The thing that people often forget about is that you could just not make turkey. You could have nothing. So, and for 1 and 15, 1 pound takes 15 minutes. But using that same logic, even though it's not as strong in this case as it is when you use ingredients, any amount that you have up to 1 pound will have a set amount of time connected to it. Same with, 2 and 30, 3 and 45, 4 and 60, that kind of thing. So it all sort of sets out the idea that it's increasing over time. Now, to do a reasonable domain versus range, I may also want to look at it from the perspective of a table. So turkey in pounds versus minutes. This is one of the few times, by the way, that minutes is not a domain value, because the amount of time I'm going to spend depends on the amount of turkey that I have. So the turkey in this case is the independent value. If I buy a different turkey, the number of minutes I'm going to have to wait changes. So it's really cooking in minutes, but that sort of thing. So 0, 1, 2, 3, and then I can go all the way up to 12. So I'd have 0 turkey would take no minutes. 1 pound of turkey takes 15 minutes. 2 takes 45 or 30. 45, what am I thinking? 3 takes 45. And then to do 12 pounds of turkey, I'm going to have 180 minutes. So what I can get out of this is to build a rule or function rule about how this is set up. So I would say maybe the function of turkey, so I'd say maybe f of t, or I should say in minutes. The function of minutes is based off of the amount of turkey that I have, and I realize now that that's a little too bright to see on the light gray, turkey times 15, because it's 15 minutes per pound of turkey. And this is the general setup of what that looks like. We'll go into function notation a little more in future, but basically it's saying the function of minutes, so the minutes are created by the amount of turkey that you have. So I'll do 15 times turkey. That's the general setup of how that goes. So using this rule, I can determine what the most amount I can have for domain with the least amount. So the domain here, of course, would be turkey. So my reasonable domain, I'm going to actually make a inequality for, greater than, less than statement that shows all possibilities. So the most turkey or the least turkey that I could actually substitute in or have is nothing. You could just say, forget you, I'm not making any turkey, so 0. But the most that I can do is 12. And I'll make a little 0 is less than or equal to t is less than or equal to 12, which is to say the amount of turkey that I can use in pounds, anywhere from no pounds all the way up to 12 pounds, because I don't have any more than 12, and I could go as low as I want all the way down to nothing. The matching range values in this case would be if you use 0 pounds of turkey, you get nothing. If you use 12, you get 180 minutes. And in the middle, we'll put the function of minutes. So that's a reasonable domain and range right there. The hardest part about reasonable domain and range, other than remembering what it is just to remind yourself that there are a lot of situations, and even though it says, 1 pound of turkey is 15 minutes, you could just say, I'm not going to bother with it. I don't want to do it anyway. You don't have to cook if you don't want to. You just have to eat. That's why, easy to prepare foods were invented, because everybody decided that for a while they were going to go 0 as the domain of cooking. But that's it. Multiple representations of functions and relations, and not a big deal.